everyone, myself Sumit Maheshwari, Assistant Professor in ABES Engineering College. Today I'm delivering a lecture on how to solve a numerical of AC quantities when we are adding or subtracting voltage or current. So we have the numerical here. If we have V1 100 sine 500t or V2 200 sine 500t plus pi by 3, V3 is 150 sine 500t minus pi by 4 and V4 minus 50 cos 500t. So first of all, we think about the all the voltages have sinusoidal form. If any vector is in cosine form, we have to convert first cos waveform into the sine waveform. So what are the method? So we know that in trigonometry, this is all sine positive, AS all sine positive in first quadrant, sine and cosecant positive. Here tan or cot, and here sec and cosec. Right? So this is 0 degree, this is plus 90 degree, this is plus 180 degree, and this is plus 270 degree. So we know that sine 90 plus theta is equal to cos theta in trigonometry, or and sine 90 minus theta is also cos theta. So we have choice here. We convert our V4 in sine form. So if we put here V4 minus of 50, this is cos theta. So we may write sine 90 minus theta. So sine 90 minus 500t. Theta is 500t in each quantities, in each vector V1, V2, V3, V4. Taking this minus sign inside. So this is 50 sine 500t minus 90 degree, because sine of minus theta is equal to minus sine theta. So we are considering this negative sign and taking in the inside the bracket. So in waveform, in polar form, we are writing here 50 an angle at an angle minus of 90 degree. This is our V4. Correspondingly V1. V1 is 100 angle 0 degree. V2 200 angle 60 degree, and V3 is 150 angle minus 45 degree. So this is our V1, V2, V3 and V4. So by using calculator, we are getting the V resultant because these are all are vector quantities. So we add in polar form like this: V1 plus V2 plus V3 plus V4 So after putting this whole expression into the calculator, we are getting the V resultant, which is 306.06 plus iota 17.13, and again convert into the polar form, which is 306.53 at an angle 3.2 degree. So this is the method where we are using calculator only. But in examination, this is the cross-check method. But in actual, we are taking xy component of these vectors and subtracting each other. Now, what is the x component? So taking the magnitude with the sine function. So 100 sine 0 degree plus 200 sine 60. This is the y component, sorry. So sine 60 degree plus 150 sine minus of 45 degree, and V4 50 sine minus of 90 degree. This is our y component. So by using the whole expression into the calculator, you will get the result of y component, which is 17.13 volt. Now, what is the x component? We are taking the whole expression for the uh, cos angle 100 cos 0 degree plus 200 cos 60 degree plus 150 cos minus of 45 degree plus 50 cos minus 90 degree. So after calculating the whole expression by using calculator, you will get 306.06 volt. So the voltage resultant is x component plus iota y component. So what is the x component? 306.06 plus iota 17.13. So this is the V resultant in the vector form. Now, if we are if we calculate the V resultant in the modular form, then V resultant is equal to under root of x component square plus y component square. So what is the x component square? 306.06 square plus 17.13 square. After calculating this, we will get 306.53. To calculate the angle phi, that is tan inverse y component upon x component. So tan inverse 17.13 upon 306.06. When we are calculating this, we are getting the angle which is 3.2 degree. So the resultant voltage is V resultant is 306 in the sine form, 306.53 with sine theta is the similar 500t plus 3.2 degree. If we calculate the RMS value, VRMS, that would be Vm by root 2. So what is the Vm? 306.53 divided by root 2. So by using calculator, 306.53 divided by root 2, it is 216.75. 216.53 volt. So if question asks to find the VRMS of the resultant vector, so you may get the 216.53 volt. So in such a way, we are adding or subtracting the either voltage or current in alternating quantities. Thank you. These are our references. This question is taken from J.B. Gupta. This is our disclaimer. Thank you.